Regression analysis is a statistical method. It is a very powerful tool in economics. We use it to estimate demand equation, supply equation, cost equation, and so forth. In this lecture, I shall give you a detail on the estimation procedure of this equation using regression analysis. First of all, what is regression analysis? As I have mentioned, regression analysis is a statistical method which is used to examine the relationship between a dependent variable and one or more independent variables. Relationship between the dependent variable and independent variable may be positive or negative. For example, if y is a function of x, where y is dependent variable and x is independent variable, y may rise due to the rise in x. In this case, the relationship between x and y is positive. On the other hand, y may fall due to the rise in x. In this case, the relationship between x and y is negative. Regression analysis helps us determine the nature of this relationship. Two major types of regression analysis are linear regression analysis and nonlinear regression analysis. In this class, we shall limit our discussion to linear regression analysis only. Again, linear regression analysis can be of two types: simple linear regression and multiple linear regression. In simple linear regression, we examine the relationship between a dependent variable and an independent variable. For example, y equals a plus bx. Here y is dependent variable and x is independent variable. Performing simple linear regression, we examine the relationship between y and x. On the other hand, in multiple linear regression, we extend simple linear regression by including multiple independent variables. If we consider the regression equation y equals a plus bx plus cz plus dr, here is only one dependent variable, which is y. But there are three independent variables: x, z, and r. Performing regression analysis in this situation is referred to as multiple linear regression. Again, we shall limit our discussion primarily to the simple linear regression analysis only. Let us now see how we can examine the relationship between dependent variable and independent variable in case of simple linear regression analysis. Suppose y is a function of x. Here y is dependent variable and x is independent variable. To perform the simple linear regression analysis, our first order of business is to express the function by a mathematical equation. We call it regression equation. Here the regression equation is y equals a plus bx. As I have mentioned, here y is dependent variable and x is independent variable. A and b are two parameters. A measures the intercept and b is the slope. Now, estimation of this regression equation means the estimation of intercept A and slope B. If you are given data on x and y, you can easily estimate A and B. I am going to show you the formula that we use to measure A and B. These formula are derived using least square estimation method. But I am not going to give you the detail on the derivation procedure. We shall just memorize the formula. If you are given data on x and y, the estimated value of b, denoted by b cap, can be found using this formula. In the formula, the numerator is n sum of xy minus sum of x sum of y, and the denominator is n sum of x square minus sum of x whole square. I repeat, the numerator of the formula is n sum of xy minus sum of x sum of y, and in the denominator we consider only the independent variable n sum of x square minus sum of x whole square, and the estimated value of a, denoted by a cap, equals y bar minus b cap x bar. You see, we get it from the regression equation. In the regression equation, a equals y minus bx. Hence, we get a cap equals y bar. We take the mean value minus b cap. B cap is the estimated value of b, and the mean value of x bar. Once we get the value of b cap, it tells us whether the relationship between x and y is positive or negative. If the value of b cap is greater than 0, it means the relationship between x and y is positive. That is, if the value of x rises, y also rises, and if x falls, y also falls. It means they move in the same direction. On the other hand, if the estimated value of b, that is b cap, is negative, it means the relationship between x and y is negative. That is, if the value of x rises, the value of y falls, and if the value of x falls, the value of y rises. That is, they move in opposite direction. If we understand this formulae, we can estimate any sort of regression equation customizing them. For example, Q is a function of price. We know price-quantity relationship is either exhibited by a demand equation or by a supply equation. So we can get either a demand equation or a supply equation. Let us first consider the regression equation Q equals A plus BP. Now if you are given data on P and Q, the estimated value of B, that is B cap, equals n sum of QP minus sum of P sum of Q divided by n sum of P square minus sum of P whole square. You see, we just rename the dependent and independent variable P and Q. Similarly, the estimated value of the intercept A, denoted by A cap, equals Q bar minus B cap P bar. Now, if we find B cap is positive, it means if price rises, quantity rises, which is true for supply relationship, and in that case, the equation we get will be a supply equation. However, if B cap is negative, it means the relationship between price and quantity is inverse. If price rises, quantity falls, which is true for demand law, and in this case, we shall get demand equation. Similarly, for estimating the cost equation C equals A plus BQ, the estimated value of B, denoted by B cap, equals n sum of CQ minus sum of C sum of Q divided by n sum of Q square minus sum of Q whole square, and A cap equals C bar minus B cap Q bar. For the revenue equation, where revenue is the dependent variable and quantity is the independent variable, the estimated value of the slope B, that is B cap, equals n sum of RQ minus sum of R sum of Q divided by n sum of Q square minus sum of Q whole square, and A cap equals R bar minus B cap Q bar. Following this notion, you can customize the formula to estimate any sort of regression equation.